Hey Everett, let's check this one out, buddy. We got to add or subtract terms whenever possible. We have the fourth root of 48 times x, y to the fourth minus y times the fourth root of 243x. And check this out, in blue brackets, they always tell you what they expect for an answer, and they want an exact answer using radicals as needed. So that tells us that we can't just blast this into a calculator, obviously. We have to put this in simplified radical notation. Okay, so we're doing fourth roots, and neither of these numbers are perfect fourth roots. And you can blast that into the internet or a great calculator if you have one. Again, you don't really need one, but what we have to do, we're going to factor out the biggest fourth root we can get out of these two numbers. Okay, so it takes a little bit of finagling, but you can rewrite this first term as the fourth root of 16 times the fourth root 16 times 3. Okay? Now I'm going to deal with my x and y's because 16 times 3 is 48. So I've just broken that up, by the way, and I'm just using the product rule. I'm rewriting both of these numbers. They're still underneath the fourth root symbol. I haven't taken the root of any of this stuff yet. I just basically factored or come up with two numbers that'll multiply to give me 48. Okay? That's all I'm doing at this point. 16 is the biggest perfect fourth because 2 times 2 times 2 times 2 is 16. That's like the biggest number I can get out of this. And I just blasted it into a calculator for a while to figure that out. So 48 is dealt with. That's going to be multiplied by the fourth root of x. That's just there by itself. I can't really do anything with that. Times the fourth root of y to the fourth. Now I'm separating these because they're two different variables, and this y to the fourth is a perfect fourth. So that's all going to cancel eventually, and we're going to be good to go there. Okay, so that's my first term. Excuse me. Minus y. Now I'm going to break this up. This is going to be y times the fourth root. 81 times 3 gives me 243. So that's the biggest one. Times the fourth root of 3 times, I'll run out of room, but you get the idea, the fourth root of x. Okay, so again, 243, I just broke that down. 81 because 3 times 3 times 3 times 3 gives me 81. So that's the biggest, like, perfect fourth, I guess, you get out of this. So let's evaluate this. Let's do some numbers here. The fourth root of 16 is 2, again, because 2 to the fourth equals 16. So my answer there is going to be 2. I can't do anything with this, I can't do anything with this, but this part I know is going to be y because the fourth root cancels out the fourth exponent. So that's going to be 2y. Now all the rest of this stuff, I'll just kind of blaster together and tack it on. So that's going to be 2y times the fourth root of 3x. Okay, I have 3 times x. Again, when you have numbers underneath a square root sign or a cubed root sign or a fourth root sign or whatever, you can multiply them and keep it underneath the root sign. I'm not doing the root or anything like that, but I can just multiply them out. So I got that. I got 2y times the fourth root of 3x. I'm going to copy my minus sign over from here. I'll change my color just to show you the other one. This part here, we're going to have y. Y is still there. The fourth root of 81 is going to be 3, and that's pretty much all I can do. So 3 times y, let me just rewrite that. That's going to be minus 3y times the fourth root of 3x. So you can see kind of what's happening here. I have like terms. I have 2y and 3y, so I can deal with that. And I have like roots as well. I have the fourth root of 3x and the fourth root of 3x. So now, pardon me, lastly, just to finish this off, we're going to combine like terms. So I'm going to subtract. That's going to give me negative y, because 2y minus 3y is negative 1, and it's way sexier if you don't write the 1. And then I will just put on that fourth root of 3x. So that should be our answer right there. Negative y times the fourth root 3x. Let me blast that in here. Negative y. And I'm going to use my higher order. I'm going to put a 4 in there. And then down here I'm going to put a 3x. And there we go. All right, buddy, so I hope that helps. A lot going on. But just think in terms of breaking things down. Kind of the same play that we've always done. I hope that helps. And if you're ever stuck with these higher order roots, the big thing like 243, you know what I mean? Say you're stuck and you're like, we know we're looking for the fourth root of 243, and you have no idea because I never do either. It's like, just start breaking it down. Get the old calculator out. Like literally, you know, I'm just using the one on my laptop here, but you get the idea. You can Google a nice one. And then just go 243. And then start picking like perfect squares, perfect numbers like that. So 81 was the one I came up with. Just, I don't know why, just random. But I was like, oh, okay, 243 divided by 81 is 3. But another way of doing that is just saying, what are any two numbers divided by 243? So if I clear that out, 243, I know probably 2 is not going to go into this, but I'll try 3. 243 divided by 3. See, there's 81 times 3. So I'm doing a factor tree or a prime factorization. And then basically you can keep going. 81, well that's 9 times 9 times 3. I'm just carrying that 3 down right there. Let's keep going. 9 breaks down. 3 times 3 times 3 times 3. That's this 9 too. And then I'll carry this guy down. Times 3. So you can see that I have 3 to the 5th equals 243. Right? I have 5 3's. But I only want 4 3's because again, up here we're dealing with the 4th root of something. So what I'm going to do is I'm just going to pick 4 of those 3's right there. So I will write this as 3 to the 4th. I'll write this as 3 to the power of 4 times 3. And that's going to, and there you go. There's my 3 to the 4. I know now what I'm dealing with there. Okay, so that's, again, that's just another way of doing it. I just stopped right here. I just said, oh, 81 times 3. I know that because that's going to be 3 to the 4th equals 81, as evidenced down here by the yellow. So they're all related. It's just different ways of thinking about it. I hope that helps anyway. Give me a shout back if it doesn't.